Hi everyone, this video will walk you through vectors and matrices in MATLAB. Now before I start, let me show you how to change the font size if you want. You can go to Environment tab, select Preferences, and here under MATLAB, click on Fonts, and here you can select any size that you want for your font. You can define row vectors and column vectors using square bracket, entering your elements 1, space 2, space 3, space 4, close the square bracket. Now you have a row vector. Or you can using this up arrow key. If you enter commas between the elements and enter, again you have a row vector. So space or comma would make a row vector for you. You can use semicolon between your elements, 1, semicolon 2, semicolon 3, semicolon 4, close the square bracket, and now you have a column vector. You can assign your vector to a variable. For example, A is equal to 1, semicolon 2, semicolon 3, semicolon 4, close the square bracket, enter, and now you have assigned this column vector to this variable A. Your variable can also have some functions and expressions instead of the elements. So absolute value of -4 as the first element, space 4 to the power of 2, close the square bracket, and now you have this row vector with the result of these expressions here assigned to variable A. You can define a range and assign it to a variable by creating a row vector, for example 5, space 6, space 7, space 8, space 9, close the square bracket, and now you have this array of numbers from 5 to 9 with a spacing of 1. You can do this in another way. If you type A is equal to 5, colon 9, enter, again you would have the same range. So this operation, this column operation, would define the default spacing, which is 1, between your first element and last element. So the default spacing, the default increment is 1. You can specify this increment by entering another number between first element and last element. So A is equal to 5, colon 2, colon 9, enter. This time you would have this range between 5 and 9 with the increment of 2. So the number you enter between the first and last number would specify the increment. You can also, so using this arrow key, you can find it here. If you use square bracket, enter, this would be the same. Another way to define a range and assign it to your variable is to use this command here, linearly space, len space, open the parentheses, for example 1, and here the different syntax appears, 1, 20, comma 20. So this time I have a row vector with all the numbers between 1 and 20, and this is the number of elements between these two elements. So here's the syntax. I will type it in as a text using this %sign. A is equal to linearly space, open the parentheses, first element, comma, last element, comma, number of elements, close the parentheses. So in this example, we have 20 elements between the first element and the last element, including the first and last element. It is the same as you use this command. A is equal to 1, colon 20, enter. So again, I would have a row vector between 1 and 20 with the increment of 1. Now, what if I define A as linearly space, open the parentheses, 1, comma 20, comma 30, and enter. This time I would have 30 elements between 1 and 20, including 1 and 20. And the entire vector is a row vector. As another example, if I type A is equal to linearly space 1, comma 10, comma 11, I would have 11 numbers between 1 and 10, including 1 and 10. So if I get back to this one here and include it in a square bracket and use this transpose operation, this time I would have a column vector between 1 and 20. So the transpose operation would convert a row vector to a column vector and would convert a column vector to a row vector. Now if I type A is equal to, so let me define a new range for my variable, 1, column 0.5, column 10. So this command would create a row vector for me between 1 and 10 with the increment of 0.5. And using the top arrow key, if this time I include this transpose operation sign, this single quotation mark, enter. So this time I have this column vector instead of the row vector. And the increment is 0.5. I can have a specific matrices and vectors using random command, open parentheses, 2, enter. This would return a 2 by 2 matrix for me with elements between 0 and 1. If I type band, open parentheses, 2, comma 3, I would have a 2 by 3 matrix with the elements which are random values between 0 and 1. So now let me define a matrix here. I would define a matrix with the name A, 1 space 2 space 3. Now if I use the semicolon, and it would return all the other elements to the next row. So -2 space 4 space 0 semicolon 2 space 3 space 4, close the square bracket, and now I have a 3 by 3 matrix. or you can use the same command, but this time using commas between the elements. But the position of the semicolon is the same as previous one. Now enter, again, this 3 by 3 matrix. So spacing for the rows and semicolon for spacing would return to next column, and semicolon would return you to next row. Now there are some matrix operations that are available in MATLAB. You can inverse a matrix. So in order for a matrix to be invertible, it should be a square matrix, and the determinant of the matrix must be non-zero. So I can inverse this matrix here. If it is it doesn't have any inverse, MATLAB would pop up an error message for me showing that there is no inverse for this matrix. So I would try it here using this inverse function. So here is the inverse of my matrix A. If I assign it to this variable, inverse of A, using the semicolon to suppress the output. So this error message shows that I need to use the correct name for my variable. It is not capital, it is lowercase. So now I have A and B. If I multiply A by B, it would return an identical matrix for me. An identical matrix is a matrix that all the elements in the main diagonal are 1 and the remaining elements are 0. So this negative with 0 means that it is a very small value below 0, but it is very close to 0. And this is a rounded value here. So any matrix multiplied by the inverse of that matrix would return an identical matrix with the same size of the original matrix. So we had a 3 by 3 matrix, and now the identical matrix is also a 3 by 3 matrix. Another operation for matrices is the transpose operation. So if I type A and use this transpose key, now I have this matrix here. So as you can see, let me compare it to the original matrix. So if you compare it with this one, you can see that the rows and columns are switched. So these two elements are switched here, these two elements, 3 and 0 here, but the main diagonal is the same. So transpose of a matrix is a matrix that the rows and columns are switched. You can extract any element or any group of elements from an array, a matrix, a vector, and so on. And this is called indexing into an array. Now suppose I define A as a 4 by 4 matrix, 1 space 2 space 3 space 4, semicolon, 5 space 6 space 7 space 8, semicolon, 9 space 10 space 11 space 12, semicolon, 13 space 14 space 15 space 16, close the square bracket and enter. Now I have this matrix. Let me copy this Now if I want to extract this element here, I need to type A, open the parentheses, 1 and 2, enter. So it returns 2 for me, the element in first row and second column. If I type A, open the parentheses, 1, comma, colon, close the parentheses, enter. Now compare it to the original matrix. I have the entire first row here. So this column is the all of the elements. If it is in the position of rows, it would bring all the rows for you. If it is in the position of columns, it would bring all the columns for you. So first row and all columns. So this is first row with all columns. Now if I type A, all rows and the first column, compare it to the original matrix, it is returning this first column for me. So all the rows of first column. If I type A, open the parentheses, 1, column 2, comma 2. Now here I have rows from 1 to 2, so these 2 rows, and only column 2, this column here. So it is returning 2 and 6 for me in the form of a column vector. Now as another example, 1 to 2, comma, 1 to 2. This time it is returning rows from 1 to 2, these 2 rows, and columns from 1 to 2. So these 2 columns. So these square matrix here, these 4 elements. Next example, I can use AND key. If I type A, and comma 1, so it is returning the AND member in column 1, 13. Now A, 1, comma, AND, it is returning the AND and the AND element, the last element in the first row, 1 and AND. If I type A, AND, comma, this all operator, column, so compare it to this one, I have the AND row and all the columns. So the last row of this matrix. If I type A, all the rows, and this time it is returning all these elements in the last column. You can use arithmetic using this AND key. If you type A, AND minus 1, comma, AND minus 1, so this time it is returning this element here. For the rows, it is considering the last element, the last row, minus 1, which would be the third row, and the same for the column, the last column, minus 1, which would be the third column. So it would return 11 for me. And I would give some more examples here. 1, column 3, comma, all the columns. So it is returning all of these columns from 1 to 3 row, so this part of the matrix. One, two, 4, comma, column. So it's actually the same as the original matrix, because I am asking for all the rows 1 to 4 and all the columns. Now that you see how we can extract the elements from a matrix, you can also change any element that you want. Say, for example, I want to convert this first element to 9. I can type A of 1 and 1, because it is the first row and first column, equal sign 9, enter. Now I have changed this matrix. Every other elements are the same, but this one here has been changed to 9. Row vector here with the name x, 1, 2, 3. Now I want to extract the third element. I would type x, parentheses 3. It would extract the third element. I can extract more elements, x, 2 up to 3. So this one would return the second and the third element, x, 2, column, n. This would do the same as the previous one, because the end element is the third element. Now I have this vector here. I can add scalar values to this. So suppose I have a is equal to x plus 2. It would return this vector for me, which 2 is added to the elements in this vector here. You can also type a is equal to x times 2, and this time it is multiplied by 2. So suppose I have another vector here, 4, 5, 6. Now x and y are both row vectors with the same size. I can add them together. Suppose I assign it to z, x plus y, and I have each of the corresponding elements added together. So 1 plus 4 returns 5, 2 plus 5 returns 7, 3 plus 6 returns 9. I can also use built-in functions in MATLAB. sqrt of x would calculate the square root of each of the elements in matrix A, and the result is a row vector, because x is a row vector. Now round of sqrt of x, so it would round these elements here, and again I would have a row vector as the output. Other functions I can use is maximum, minimum. So max of x is 3, mean of x is 1. Also we have mean as the average. The mean is 2. In MATLAB we use mean. In Excel and Visual Basic we use average command. So now suppose I have a vector of mass 10, 20, 30. I use the semicolon to suppress the output, and my acceleration is 4, 3, and 2. Now I want to calculate the force. So force is mass times an acceleration. So force is mass asterisk A. Now that I am multiplying these two vectors, I need to use element-wise operation. So instead of asterisk alone, I need to also include a dot here. So dot asterisk is the element-wise multiplication command that I can use. Now if you hit enter, it would return the force for me, multiplying the corresponding elements here. So 10 times 4, 40, 20 times 3, 60, 30 times 2, 60. Now what if I don't use this dot here and enter? You would see that MATLAB would pop up this error message, and it is asking to use this element-wise multiplication operation. So when you're adding two vectors with the same size, or you're subtracting two vectors with the same size, this dot operation is not required, and actually it is not allowed. But when you are multiplying two vectors with the same size, or dividing two vectors with the same size, you need to use this dot operation. Now suppose I divide f by a. So I would use this dot operation, element-wise operation. And now I have this vector, which refers to my mass, 10, 20, and 30. Now if I type mass, enter, you can compare it with this one here. So when I'm using this element-wise division operation, it is returning this vector, which is equal to mass. Now what if I don't include this dot here, f divided by a? So this time it is returning a scalar value, which is not what we were expecting. So for division and multiplication, and also for exponentiation, you need to use element-wise operation, this dot before the operation sign. But for subtraction and addition, this element-wise operation is not allowed.